What is it that takes us further into the future? It exists in every visible detail. And somewhere in the unexplored possibilities, we imagine countless times that dry deserts become lush oases. And now it has become a reality. Sunlight spur a new ray of hope. Make the earth green and breathe new life everywhere. The size from rural to urban areas get simplified gradually. Conserve the nature and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world. To unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society.
Hello, ladies and gentlemen. Welcome to Huawei SNEC 2021 Global Virtual Summit Europe. I'm Liu Xuan, Marketing Manager for Smart PV and Huawei. Digital power is the foundation of the digital world. Energy generation and deployment require strategic planning. And solar and renewable energy becomes the main energy source. Huawei, as a key industry player, is working closely with our global customers and help them to achieve energy and digital transformation. This year, for our friends and partners who are not be able to come to Shanghai during SNEC 2021, we will be bringing you to the SNEC exhibition and showing you the highlights of our latest solutions with an exciting new product launch and all-scenario solution introduction. We believe Huawei innovative digital power will not only create commercial values, but will also contribute to the sustainable development for all. We hope you would enjoy this virtual summit and get to know more about how we lead in power digitalization for a zero-carbon smart society. Now, let's welcome Mr. Hou Jinlong, President of Huawei Digital Power, to give us a welcome speech.
Distinguished guests, ladies and gentlemen, good evening. First of all, on behalf of Huawei Digital Power Technology Company Limited, I'd like to extend a warm welcome to all of you for attending this dinner. And I want to extend my heartfelt thanks to all customers, partners, and media representatives who have always cared for and supported Huawei Digital Power. Today we have had a very fruitful discussion, and we are grateful for your coming. At present, carbon neutrality has become the consensus and mission of the world. For China, the carbon neutral 3060 target will be the biggest and most certain event in the next 40 years. This is bound to be a broad and profound economic and social transformation, which would not only mean a revolution in energy production and consumption, but also an opportunity for all-round upgrading in all walks of life. It will affect all aspects of people's production and life. It is a challenge, and it also presents huge industrial and commercial opportunity. Looking at the global energy mix and system, it is an inevitable trend to build a new power system based on new energy sources. Photovoltaic is playing an increasingly important role in the high-quality development of renewable energy, and the photovoltaic industry has embraced historic opportunities. We believe that smart PV will become the main power generation system, and PV will become an inclusive energy source. The cost of PV power will continue to decrease, and renewable energy will become increasingly competitive, helping smart PV become the main energy source. Huawei's digital power, just recently established, is committed to powering 800 million people without electricity worldwide, and enabling more than 7 billion people around the world to use clean, efficient, and stable energy. Energy storage has become a necessary enabling technology to drive new energy from adaptive grids to enhancing grids. In a new power system, energy storage is distributed in scenarios such as source, grid, and load, and acts as a water reservoir and a grid regulator and a stabilizer. In our view, batteries are not equivalent to energy storage systems. The energy storage system is an integrated system that integrates electrochemical, power electronics, digital, heat dissipation, and AI technologies. The controllability of power electronics and the digital technologies resolves battery inconsistencies and uncertainties, ensuring the efficiency and the safety of the energy storage system. This is the mission for this industry. We want to be driven by both technologies and the market to facilitate industrial development. Low carbon and zero carbon will run through every aspect of production and life. All scenario zero carbon solutions such as zero carbon power generation, zero carbon mobility, zero carbon ICT infrastructure, and zero carbon buildings are used to achieve green power generation, efficient power consumption, reduce energy consumption costs, and build zero carbon campuses to achieve zero carbon cities. In the carbon neutral era, Huawei Digital Power will integrate digital and power electronics technologies, focus on clean power generation, transportation electrification, green ICT infrastructure, and energy storage, and work with industry partners to drive the energy revolution and build a green and a bright future. To address this issue, we will launch an all-scenario smart PV solution to facilitate zero carbon power generation and bridge the power gap. Today, it is a great pleasure to gather with you at the SNEC and to witness and experience the development and the growth of the PV industry with all of you here. Looking forward to the future, I want to thank all the partners here for your perseverance that have really made it possible for the PV industry to grow. I hope to embrace change with all of you, seize the opportunities given by the times, and jointly contribute to the goal of achieving carbon neutrality at an early date. Finally, I hope everyone enjoys a nice and wonderful evening. Thank you.
Thank you, Mr. Hou. Now, let's welcome Mr. Chen Guoguang, President of Smart PV Business, for the new product launch at this summit.
Distinguished guests, ladies and gentlemen, let me again extend our heartfelt welcome to you for attending this dinner. SNEC every year is an opportunity for new and old friends to meet, and also an opportunity for industries to exchange thoughts. The industry launched its latest products and solutions. Huawei leverages this opportunity to release our latest R&D results to the industry. In the past decade, smart string inverter has been the cornerstone of our innovation, and we have been pushing the digital and intelligent transformation. Facing the future, building a new power system is our goal. We will release the all-scenario smart PV and storage solution, which will again lead the PV industry in the future and make PV the main source of energy in the new power system. First of all, I want to thank customers and partners around the world for your trust and support. In 2020, under COVID-19 and complicated external challenges, we realized over 42 gigawatt shipments in 2020 and maintained world number one for 6 years in a row. By May this year, we have 175 gigawatt of total global shipments, and every year we produce 224 billion kilowatt hour of clean energy, which is Beijing plus Shanghai total electricity consumption. Our teams remain in the field together with customers and partners, ensure project delivery, to ensure supply, cooperation, and service continuity. More importantly, around the world, there are 800 million people don't have access to electricity. As PV costs dropped continuously, we can use PV to provide them with electricity. In Cameroon, for example, our PV and the storage solution have provided electricity for 300,000 people and 35 villages around the world. 2.2 million people have been powered now thanks to the PV products. As the energy develops rapidly in China and other countries, the new energy installed capacity has achieved more than 50%. In Mexico and Australia, the local grid requires PV plants to provide the same features that traditional power systems have, and China's HVDC requires stable operation of a new energy in SER 1.5. Before, PV and storage stations were built in remote areas, and accidents only impact the system itself. But today, PV and power storage are more and more in the campuses, buildings, homes, and be part of people's production and life. And physical and property safety are vital. In Australia, United States, and in Europe, the DV arcing of a PV and a faster shutdown has been made a mandatory requirement. All of the rooftop PV and the storage must have these capabilities. In future, for PV to become the main source of energy, the grid connection and the safety are the mandatory requirements that must be met. In order to achieve carbon neutrality, the key is to build a new power system based on new energy. About the new power system, there are 4 features. First, high proportion of renewable energy. In power generation, PV, wind, and storage will replace traditional energy and become the main source of energy. For the utilization, the source, network, load, and the storage will be part of the home and campuses, from traditional power consumption to a consumer to producer transmission. Number 3, high intelligence, high degree of digitalization. In the future, the grid will also become digitalized. Generation, distribution, transmission, and utilization will all be based on power electronics.
Next feature is high degree of digitization. In the future, a large number of PV stations, storage systems, distributed storage systems, and electric cars need to be coordinated in a unified manner. We need to rely on digital technology so that all the systems can be controlled. Going forward, the stability of new electric power systems will be the digital technologies. In digital and electrification technologies, Huawei has extensive experience. We have 5 core technologies, from underlying technologies to applications. We target sensing, connectivity, cloud, data, and algorithm. We have presented 4 large-scale application scenarios. We will also build one cloud for streamless power generation, storage, and consumption, and help to build a new power system and helping to achieve carbon neutrality. Now, let me show you a small video about the all-scenario smart PV and storage solution. In this video, it shows our solution from 1.0 to 8.0. I'm very thrilled. Over the years, we have stayed customer-centric and keep innovating. We have overcome one difficulty after another. We have brought industry with numerous innovations and created more value to our customers and partners. We have received recognition and rewards from them. The solution we're launching today is also supported by our partners. Now let me give you more details about this innovation. The first solution is FusionSolar 8.0 Smart PV Generator. The traditional PV generation is supplementary generation unit. Going forward, to become the primary source of energy, PV needs to reduce the unit cost. It also has to be fully compliant with the most advanced technologies. To achieve that, we have achieved the 1,500 volt bipolar smart string. This will help us to achieve the synergy of PV and storage, achieve the greatest efficiency and the quick scheduling and unified management. So this architecture can help PV stations reduce LCOE. The Smart String ESS is just like the string inverter we launched 10 years ago. It can greatly increase efficiency. We also put forward grid forming. This is the key algorithm in smart PV solution. It can turn the PV into a voltage source. Using the string solution and grid forming, we can achieve adjustable frequency and storage solution so that PV stations can really become the smart PV generator. Why can the architecture reduce LCOE? With an increase of voltage, more energy can be transmitted. We use 1,500 volts to achieve higher voltage and give us more sub-array. Using the 3,000 volt, we can achieve 3 times efficiency. We can save 10 cents per watt. Our solution features optimal investment, higher yields, smart O&M, and safety and reliability. And I want to emphasize that using our architecture, it is symmetric design. It is fully in line in the low voltage requirement. It applies to all the requirements of the industry. We can achieve industrialization and also more efficiency. This is more details about the Smart String ESS. When we just entered the PV sector, it used centralized inverter. One control unit manages about 200 strings. They cannot be actively managed. So by presenting the string ESS, one control unit manages 2 strings, increasing the precision by 100% and greatly increasing the accuracy. Today, we see that the storage industry is just like the PV sector 10 years ago. One control unit manages 2,000 chips. The inconsistency of chips affect the storage efficiency. We have greatly raised the management efficiency by 100 times. This is the key feature of the Smart String ESS, that is precise management. This solution features more energy, which increases discharging energy by 15%, and simple O&M, which saves 170 RMB yuan per megawatts year. It is also safe, highly safe and reliable, which achieves active alarms, system quadruple safety protection. We'll be able to address the inconsistencies and uncertainties in lithium batteries. The efficiency of charging and discharging can be increased by 15%, and the expected storage cost of LCOS can be cut by 20%. Using this architecture in our day-to-day operations, it can reduce the SOC of batteries. We don't need to have manual checks at the stations. We can also have hybrid use of old and new batteries. This reduces the O&M costs by a large margin. Grid forming is a technology that enables PV voltage source attributes and aligns grid ties features with synchronous generators. We need to completely overhaul the control. We need to proactively control the frequency and voltage using the 1500 double string. And grid forming, we have achieved a good mechanism to control the voltage source. Recently, together with Qinghai Grid, we did a research, and our research shows that PV generating mode has increased the efficiency of renewable energy access. It has boosted the efficiency by 13%. Under the current grid, as long as you have installed this system and you can have additional 1.3 gigawatts of renewable energy, this is a great boost to the use of renewable energies. This is the greatest value that can be brought by the smart PV generator. For PV to become a primary energy source, security is the foundation of everything. We believe there is room for improvement in safety. DC protection has clear weaknesses. When there are circuit breaks, DC will encounter challenges. In severe situations, there will be fires and other hazards. So this year, this has been a key focus of the industry. We have achieved 3+4 safety protection for smart PV and storage system. On the AC side, there is also hazards due to low voltage. There can be damages to the boxes and fires. We have released a new solution that increases the safety of low voltage. In middle voltage, we also support switch and disconnector fuse. We use AI means to identify circuit breaks, which greatly improves the safety of storage systems. We use modular PCS architecture to achieve 4-level safety protection and coordination. On top of great big grid power stations and generators, we have also launched the Green Residual Power 2.0. On top of the 1+3 architecture unveiled last year, we have introduced the 1+3+X architecture for smart energy use. We have secured all the steps in the entire process, implemented smart scheduling. On the power generation, we can have 28 kilowatts of power on rooftops. The power generation volume is 30% more, and we are also able to achieve higher energy volume. In another case, the traditional method is only half as good. To give you more details, this solution includes yield increase by up to 30%, battery charge and discharge capacity improved by 10%, consumption rate increased by 10% and more safety. When it comes to safety, we are using AI smart protection and to achieve shutdown within 0.5 seconds to prevent fire. We have also achieved zero voltage in emergencies, providing more safety.
The storage system has been integrated with AI detection for proactive prevention, and we also have reactive security. Through this, we make sure that there is a system-level proactive security for home green power. And today, we launch a digital feature, which is AI-based PV storage synergy. We know that PV power production and utilization are not matched during daytime, and there's only 60% of power generated used, and the rest will be sold at a much lower price. However, AI-based PV storage synergy can solve that problem efficiently. Through AI algorithm, we bring in the weather pattern and the user utilization pattern for big data analytics, so that under different weather conditions, the PV power generation and the home power utilization situation can be coordinated, so as to achieve the optimal match under each scenario. Let me give you several modes. In the sunny mode, if we forecast that during noon there is a PV peak shaving, then AI will tell the storage to reserve some space to accommodate the surplus power. Under rainy day, our algorithm will tell the storage system to charge the night before during the valley price period. If we believe we have PV power to go to the grid, we can see which families can be prioritized, such as laundry machine, EVs, and others. These are the units that can be configured flexibly by AI. It was 60% of self-consumption rate during PV only, and now 85% under Green Home Power 1.0, and will be 95% under Green Home Power 2.0 era. Apart from this solution, today we bring the Green Business Power 1.0 through Smart PV Optimizer and ESS storage. We can provide 4 scenarios. All the features are based on the common architecture. In Jiangsu, one factory, we had a 156 kilowatt rooftop PV plant. Intelligent component have solved the blocking by a water tower issue. The PV plant capacity was improved by 6.3%. We work with PetroChina in one plant in Wuhan. PetroChina is worried about security, but they know that we can achieve fast shutdown and arcing prevention on the rooftop. This solution was quickly adopted in the PetroChina sites. Around the world, there are a lot of areas without access to mains or only have a weak mains. We provide affordable off-grid PV replaces diesel generator solution. There are about 50 million diesel generators and an increment of 5 million DGs every year. The fuel cost is high, so is the maintenance cost. The noise, the pollution, and the reliability are all big problems. The core of the off-grid PV solution is the storage, mains, and the DG, smart scheduling technologies, as well as AC and a DC reliable power supply, which can reduce the power generation cost by 60%, and it can replace the traditional DG to protect the environment. We can cover from kilowatt to megawatt, from city to remote areas, in Cameroon, in Africa, in Sea Island in China, and among many other regions around the world. Lastly, we use Energy Cloud to fully connect all scenarios. For the PV side, through refined component management, we can monitor the condition of each module. For the storage, we will provide modeling of 3D for the storage. And also, BMS on the cloud can also support this management. The Smart IV curve diagnosis is the only one in the industry that reach L4 for all the aspects, which can reduce more than 20% of O&M cost of power plants. The SDS features intelligent DC power generation system. It can automatically identify shades and unsunny weathers. In one project in Guangdong, for half a year, SDS power plants generates more than 1.6% of power than others. Through AI-based PV plus storage synergy, we keep reducing O&M cost and improve maintenance experience and realize the autonomous driving of a PV and a storage. In the carbon neutral time, we focus on digital and power electronics technologies and promote the energy revolution and build a green and a bright future together with industry partners. Thank you.
Thank you, Mr. Chen. Today is the first day of SNEC, and Huawei's exhibition hall is still packed with people and a warm atmosphere. However, we have tried our best to record the pageantry of each exhibition booth for you. Now, we will take you through all the solutions presented by Huawei and SNEC.
Hi, my name is Helen from Huawei marketing team. I'm now broadcasting from SNEC 2021 in Shanghai, the largest solar and renewable energy exhibition. There are many innovations and cool solar techs, and we expect more than 2,000 companies and 260,000 visitors to the exhibition this year. As we know, the only way to achieve carbon neutrality is through energy transformation. That means low carbon energy, electrification, and intelligence, which are our key paths forward. We can use this to manage watts and data flows to manage energy flows. The end goal is building more flexible, open, and intelligent energy networks. Together with renewable energy, digitalization will be a powerful driving force for a greener, more sustainable society. This year at SNEC, we are presenting our full suite of products and latest innovations from our digital power business, ranging from utility-scale energy storage to zero-carbon ICT solutions. The digital power market is poised to reach more than $80 billion by 2025. Let's check out the best of Huawei from SNEC 2021. In terms of energy supply, solar PV and wind power will gradually become our primary source of energy. Solar and wind power will increase from 20% of total supply to over 86% by 2050. This will be a key factor in zero-carbon power generation. This year, we have launched FusionSolar all-scenario PV and storage solution, which unlocks the advantage of smart string design, such as intelligence, modularity, multi-MPPT, high protection, and so on, and comprehensively reinvents the power electronics architecture and creates the world's first Gemini plus-minus 1,500 volt design. This architecture design can help to support larger subarrays, higher voltages, thus could reduce LCOE by 7% and even enhance the grid, redefine the PV plant standards, and it could adapt to large-scale wind, solar, storage projects as well. As you know, there are two main topics that are widely discussed in the industry currently: carbon neutrality and energy storage. In the traditional energy storage solution, multiple modules are connected in series into a rack, and multiple racks are connected in parallel. Thousands or even 10,000 modules are coupled with each other. If one module fails, it will affect the others. For our solutions, we could help our customers to avoid this issue and reduce the LCOS by up to 20%. How do we do it? Our solution is through the battery pack level and rack level optimization. The solution can achieve more refined management with the accuracy of no more than a dozen batteries, which is far better than the traditional solution. Besides, the refined management can achieve precise management of each pack with optimized depth of charge. which improves the available power of the system. On the other hand, this innovative design can support the mixed use of new and old batteries, and the phase charging can help customers to save initial investments. In terms of energy consumption, electric energy will surpass oil by 2050. It will go from 20% of total consumption in 2017 to 49% by 2050, and it will eventually replace fossil fuels entirely. For commercial and industrial customers, we are bringing you into our zero carbon comfort zone and walk you through our solutions to help business and organizations to reduce their carbon emissions with many cool technologies. Many organizations in the world are facing the challenge of high electricity bill. We are presenting our full PV and storage solution for the first time for our CNI customers, where we are showcasing real customer case of pure PV, pure energy storage, and PV storage and charging, and finally off-grid scenarios. And for ICT sectors, earlier this year, we have released our latest offerings in the energy solution, the Zero Carbon Network. The Zero Carbon Network is mainly designed to help telecom operators worldwide to reduce their energy costs, increase green power generations, and to realize carbon neutrality in their business operations. As digitalization continues to change the way we live, energy costs increase sharply and the demand for energy also increases. Huawei's Zero Carbon Network solutions is integrated by Huawei's intelligent power cloud to realize the carbon neutral targets. First, the simplified site can simplify each telecom base station to minimize size and energy costs. Second, the simplified equipment room utilizes prefabricated and modular components to reduce costs of both the new room and the extension of the existing rooms. Thirdly, the simplified data center will use indirect evaporated cooling and eye cooling to reduce cooling costs up to 70% and use cloud operation and maintenance to increase O&M efficiency by up to 35%. And finally, green power for all utilizes renewable energy, including wind and solar power, on and off-grid to reduce carbon emissions. At the individual level, it's everyone's dream to live in a green and smart home, where our energy is coming from renewable sources like solar PV, and also we could manage the energy with smart devices. More than 500,000 homes from 100 countries have adopted Huawei Smart PV residential solution. This year, we have also upgraded our offerings and we call it 2.0 and make our solutions more efficient and smart. With the optimizer and our flagship product Luna 2000 Smart String Energy Storage, our residential portfolio could support more scenarios, whether it's grid connected or off-grid, and it could help our customers generate more than 30% more energy and achieve zero electricity bill. We are also presenting a new feature here, PV and storage and consumption AI synergy function, which helps to make your PV system smarter. Through our FusionSolar app and big data analysis, we could analyze different scenarios and help to optimize how you utilize the energy, either directly from the PV system or from the batteries. Besides living in a green home, we could also travel with green vehicles. You might have heard about the recent news that Huawei has helped many car manufacturers to build smart EVs, for example, Arcfox Alpha S and Series SF5. One of the key features that people are looking for when choosing EV is the charging experience. Huawei provides Drive One on the vehicle to help EVs to provide an optimal charging experience for the user. Within 10 minutes of charging, Arcfox Alpha can extend the mileage to almost 200 kilometers. We also provide solutions for charging stations, and the solutions have been widely adopted in China and overseas. The energy sector requires many parties to work alongside each other. With profound experience in information technologies, including big data, AI, and cloud, we can see the potential and the need of creating an energy cloud, which will help to manage energy production, transmission to consumption. Our goal is to speed up the digital transformation of the energy sector and promote a zero carbon and smart society. To date, Huawei's digital power solutions have been deployed in 170 countries and regions. They serve more than one-third of the world's populations. These solutions have generated 325 billion kilowatt hours of electricity from renewable sources. That's like planting 220 million trees. Huawei's greatest value is through technology innovations to help more industries to reduce carbon emissions, accelerate energy transformation to build a low-carbon society, and achieve carbon neutrality. If you would like to know more, please stay tuned and our expert will be sharing more details, and we look forward to seeing you in our next event. Stay safe and take care. Thank you.
Energy storage will be the key direction of new energy development in the future. How can Huawei's smart street storage solution meet the challenges? We will also launch FusionSolar 8.0, which will be redefining global PV plant standards.
Hello everyone, I'm Mei Chen from Huawei FusionSolar. Today I will guide you through this most compelling new products at SNEC, FusionSolar Smart PV and Storage Solution. Let's start with FusionSolar 8.0, the first Gemini plus minus 1500 Smart PV solution. FusionSolar 8.0 consists of 4 core devices: Virus 2000 Smart String Controller, Sun 2000 Smart PV Hybrid Controller, Luna 2000 Smart String ESS, and Jector Smart Transformation Station. Traditional string inverter provides voltage boosting and invertering functions. Gemini is the first bipolar string inverter. Smart string PV controller and smart hybrid controllers achieve 3000 watts with plus minus 1005 watts design in the DC side. The smart PV controller functions as MPPT and voltage booster in the DC side. There are 8 MPPTs in one device. Each MPPT connects no more than 4 PV strings. Smart PV controller supports high current modules, while the input voltage on the DC side is still 1005 voltage. The smart hybrid controller functions as a bidirection inverter with rated power of 315 kilowatts at 40 degrees. FusionSolar 8.0 supports DC coupling of PV and ESS and uses advantaged algorithms to achieve 4 major goals: optimal investment, higher yields, safe and reliable, and smart O&M. While achieving higher voltage, FusionSolar 8.0 meets all existing standards and regulations related to electrical and safety regulation for the PV power plants, supporting max sub-arrays with higher current modules and higher DC-AC ratios to provide higher power generation, lower capex, and system cost. I will go into more details. First, the plus minus 1500 system architecture uses higher voltage and therefore reduce current. Signal cables can be used, saving cable cost by 0.83 cents watt. Second, with the sub-array size expansion, the number of sub-arrays will be reduced, meaning fewer transformer and medium voltage devices will be deployed for lower costs. At the same time, the occupied space and construction cost of main circuit and transformer laid inside the sub-array, the number of ports and terminals of medium voltage booster station, and the number of monitoring and fire extinguishing facilities in the sub-arrays are reduced accordingly. With all those savings, the overall equipment and construction costs can be reduced by 0.36 cents watt. Third, the number of transformers in the super sub-arrays is reduced, and the MCCBs are replaced by fuse switches to implement low voltage zero-arc flashing as well as on-load cutoff. Therefore, the O&M cost of medium voltage side will be further reduced by 0.1 cents per watt. In addition, Huawei FusionSolar 8.0 solution can effectively support the DC compelling solar storage solution. Compared with the traditional AC compelling solution, Huawei FusionSolar 8.0 solution saves the equipment and construction costs of PCS, energy storage transformer, and cables, which consequently reduce the system cost by 4.7 cents per watt. One significant advantage of Huawei FusionSolar 8.0 solution is that it can increase energy yields by 2%. In the ±1,500 bipolar string architecture, the current between smart PV controller and between smart hybrid controller can compensate for the AC air loss and increase the energy yields by 1%. FusionSolar used the ±1,500 watt bipolar PV string architecture. The cable loss is reduced by 0.23% compared with that of traditional PV string controllers. The intelligent PV string controllers supports output power overshooting and compensates for high voltage DC cable losses. Its energy yield is also higher than that of traditional PV string controllers. Huawei Smart Tracker Control Algorithm analysis mass data from tracker performance experience and use AI to analyze the optimal angle for trackers to avoid shading and maximize the output power of each inverter. Also, SDS can smartly identify cloudy days with power fluctuations and adjust angles accordingly to collect more solar energy. Smart Tracker Control Algorithm has been operated at several solar plants in China and India. In one Guangxi plant, after the 4 months operation, the energy yields with Smart Tracker Control Algorithm increased by 1.69%. Huawei FusionSolar 8.0 solution provides reliable DC side and AC side safety protection. On the DC side, Smart String Disconnector is deployed to protect the power plants. In the traditional central solution, short circuit cannot be protected by combiner plugs, as the fuses cannot be disconnected instantly. The short circuit current ranges from 331.2 amp to 444 amp, which poses great safety risks. In other string solutions, as the capacity of PV module and inverter keeps rising, more and more strings are parallel to connected in one inverter, increasing risk of malfunction and even fire. Huawei Smart PV solution accurately detects reverse current connection, internal short circuit, and AC-DC isolation faults. The switch can disconnect the inverter with failure within 15 milliseconds, ensuring PV plant safety. On the low voltage AC side, Huawei uses zero-arc knife fuse switch to ensure zero arcing and high reliability. On the low voltage AC side, Huawei uses zero-arc knife fuse switch to ensure zero arcing and high reliability. Currently, MCCB is often used to effectively cut off faults. However, when MCCB is damaged, it generates spray arcs and requires high-level isolation and protection design. Huawei introduces the strip-type fuse switch disconnector to achieve zero arcing at low voltage. In an on-site test, the Huawei disconnector withstands 50 amperes opening and switches off twice with zero arcing. On the high voltage AC side, Huawei uses smart European transformer and independent SF6 medium voltage Rainman units. At present, the cheap and low capacity American transformer architecture is widely used in China. This transformer uses medium voltage fuse and oil immersed load switch, and the power supply reliability is poor. The protection function is simple, as only the transformer short circuit protection is supported, whereas Huawei's solution uses internal vacuum circuit breaker to extinguish the arc in vacuum mode for high reliability. In terms of operation and maintenance, Huawei Smart PV and ESS management system implements string-level monitoring and integrates smart IV diagnosis and SDS functions. When monitoring PV plants, we can see the KPI data and accumulated energy yields on the PV plant page. On the PV plant interface, we can see the topology connection of smart array controller and the smart PV controller in our inter-array. The detailed data of each string can also be seen. In smart IV diagnosis, we can see historical scanning records and main data, including the number of sub-arrays, faulty smart PV strings, total number of PV strings, diagnosis progress, and diagnosis duration. Then we can select a diagnosis record to view the detailed diagnosis results, including whether each PV string is faulty, fault type, fault IV curve, and fault ratio. In the form of pie charts and curves, the system analyzes the fault type based on the measured IV curve. This is a Level 4 certificate issued by China General Certification Center to Huawei Smart IV Curve Diagnosis. The accuracy, consistency, and recurrency rate of Huawei Smart IV Curve Diagnosis reach over 95%, which is the highest level in the industry. In SDS, we can view information about multiple sub-arrays. For the two sub-arrays with and without SDS, we can compare the energy yields curve and see the energy yields improvement effect of SDS. FusionSolar 8.0 is future-oriented, moving from supporting power grids to enhancing power grids. The PV and storage coordinated control algorithm turns the PV system from an uncontrollable and unstable current source into a stable voltage source, creating the PV generator. In FusionSolar 8.0, a great variety of advanced ICT technologies such as AI and cloud are catalyzed and organizingly integrated with PV. Modules, trackers, cables, array controller, energy storage, grids, and inverters are fully coordinated and fully coupled, including the latest intelligent IV 4.0 diagnostic technology. This embeds intelligent PID protection, SDS algorithm, intelligent grid connected algorithm, etc., which fully release the potential of each string, create a zero-touch O&M experience, stronger grid support capacity, and so the power plants have three-dimensional awareness and create an open and efficient intelligent PV and storage system. Now let's move on to the next section, energy storage. This is the first physical display of Huawei Lunar 2000 Smart String ESS. Come on, let's take a look together. Smart String ESS is a standard 20-foot container with rated capacity of 2,064 kWh, a very high power density. As we can see, 6 battery racks are connected in parallel. Each rack has 21 battery packs in series. Each battery pack is 16.384 kWh. Each rack is connected with one DC-DC module, then paralleled into DC bus, and energy is separated into individual PCS. Based on the distributed ESS architecture, the Smart String ESS solution uses innovative technologies such as pack level and rack level optimization, distributed cooling, and modular design to achieve higher discharge capacity, optimal investment, simplified O&M, and higher safety and reliability. And it will ultimately bring about LCOS reduction of over 20%. Sounds quite cool, doesn't it? Let's go further and explore how Huawei makes it. In traditional centralized solution, multiple battery packs are connected in series in one rack. So once capacity attenuation occurs between backpacks, there will be a series of mismatch problems. Besides, during a discharge process, as long as one battery pack is fully discharged, the rest of battery packs with vacant capacity cannot be discharged anymore in order to avoid overcharge, resulting in a huge waste of battery capacity. The pack level optimization in our Smart String ESS solves this problem. The optimizer in parallel with battery packs ensures that every pack can be fully discharged and charged. When battery pack reaches a fully charged or discharged state, the optimizer in the pack starts to bypass the battery pack so that the other battery packs can continue charging and discharging, and every pack can be fully utilized regardless of cell difference. In actual operation, the internal resistance difference of battery racks could be huge due to factors such as factory tolerance and operating environment differences. In each energy storage system, 6 to 12 battery racks are connected in parallel to the DC bus, and the voltage are forced to be aligned. So a battery rack with a lower internal resistance has a larger current and a higher charging speed. It brings about 2 bad effects. Number 1, when a single rack is fully charged, the whole system stops, and the parallel mismatch causes the discharge volume to decrease. Number 2, the uneven flow of each rack is huge, which leads to the heat difference of each rack, aggregates the mismatch, and easily leads to thermal runaway. To solve the above issues, Huawei Intelligent Rack Level Management allows the racks to run differently, eliminating the mismatch between parallel racks, maximizing the potential of each battery rack, and increasing the discharge capacity throughout the lifespan by 7%. In addition, Huawei's solution ensures that the uneven current of each rack is less than 1%, avoiding the security risk of bias current. In Huawei Smart String ESS, each battery rack has an independent air container, reducing the temperature rise difference between battery racks and slowing down the battery capacity attenuation. Besides, Huawei's unique Baltic hybrid air dust design enables air intake from the rear and air supply from the side and the top to ensure the cooling capacity of the cells is similar and reduce the operating temperature difference of the cells. Therefore, the temperature rise inside the container is less than 3 degrees at 0.5 C rate, and the battery lifespan is extended by 50% for higher discharging energy in the lifespan. Safe and reliable operation is achieved by using advanced power electronic technologies as well as ICT technologies such as AI and cloud BMS. To avoid fire risk, Huawei Smart String ESS deploys 4-level safety protection from cell level strengthening, pack level shutdown and isolation, rack level short circuit detection, and 2-tier protection, to system level fire detection and fire extinction. Huawei manages to prevent safety hazard from malfunction protection, early failure protection, and zero runaway suppression for higher system safety and less fire risk. Short circuit inside the batteries is a major cause of battery pack fire. AI-aligned smart internal short circuit detection can detect battery fire risks in a timely manner based on subtle changes of cell charging curve, calculate the internal short circuit resistance, capture the slight deviation of charging curve, accurately locate potential risks, and warn of fire risks in advance. To conclude, the Smart String ESS solution adopts the innovative string architecture, digital technologies, and module design to implement refined energy management, increasing discharge capacity, achieve optimal LCOS, and eventually achieve a transition from PV parity to PV and storage parity.
Mr. Alvaro Zano, Solution Manager Mr. Trapper Martins, Service Manager will guide us to visit this project with more details about Huawei Sun 2000 185 KTL inverter and STS solution. Let us check out together. It is time for the online tour to span 34.8 MW Troneros STS project.
Hello, good morning. I'm Charlie Ferrero, PV Service Manager from Huawei in Spain.
Hi, I'm Alvaro Zanon, Senior Solution Manager of Huawei in Spain.
We are in the photovoltaic plant of Torreneros that has a peak power of 34.8 MWP and a rated installed power of 30 MVA. Regarding the plant configuration,
Modules of both 400 and 405 watt have been used, with an approximate mix of 50% each, which have been connected in a series to form strings. Then those strings connect directly to the inverter without using junction boxes. Most of the inverters in this case have 15 strings per inverter, and another some more to adapt to the trackers per the plant configuration. Trackers are P2, with 2 modules in portrait that can fit a total of 3 strings per tracker.
in the plant Huawei, 195 units of Sun 2000 inverters have installed 185 KTL H1, which are connected to 7 transformer centers called STS, 5 of which are 6.3 MVA and 2 of which are 3.15 MVA, which is what we're going to show you next.
Come with us to see the inverters and the STS. Here it is, Huawei's 185 KTL. It's one of the latest inverter one we have offered to the market. We'd like to show it to you in this Torreneros plant in which we have 125 units installed. It's an inverter that weighs only 84 kilograms. The power density is very good, 185 kilowatts in 84 kilograms. It has on both sides a pair of handles so that it can be easily mounted. Let's see its features, communications aspects, the DC and AC sides, and its installation. We'd like to start with the DC side, where the modules and all strings are directly connected. This project utilizes 28 PV modules in a series per each string, which are cabled under the modules, then go down the tracker post, and coming out from the cabling trench, the cables resurface. Then they are connected to the inverter via the Staubli brand MC4 terminals, which come included with the inverter. Both males and females, positive and negative. A very important feature is that this inverter does not have any fuses. It has 18 inputs for 18 strings that connect to 9 MPPTs. So there are 2 strings per MPPT, which means that this inverter does not have any fuses. The DC connecting cable used is usually 4 to 10 millimeters squared. In this case, they're 4 millimeters squared. On the bottom, there are 3 DC connect switches, 1 per 6 strings, so that if maintenance is required, part of the modules that are connected to the inverter, you can disconnect using the DC switch and leave the others connected. The inverter can continue to operate at 1/3 or 2/3 load. On the AC side, all cables are connected to this little box. In this case, aluminum cables being used are 300 millimeters squared, but are usually 240 millimeters squared, but even 185 millimeters squared can be used. It is also possible to have the option of using a single-core 3-phase cable instead of the 3 unipolar cables. The inverter has an IP66 enclosure rating, which allows installation in any type of conditions. While it's true we have this inverter installed in desert conditions at very high altitude, as well as near the sea, etc., this inverter will always be the same. That is to say, there are no high-altitude models for snow, etc. Okay, that's why it's an inverter that's applicable in all markets. Included with the inverter, in the same box, we also provide a mounting plate, which is placed on the inverter's backside, so that the installer must only attach to the tracker structure. In this case, there are 2 horizontal aluminum profiles on which the mounting plate is attached, and then the inverter is mounted. Regarding inverter cooling concept, we call it smart cooling, which is a type of natural convection which is aided by fans. So that when the outside temperature is not very high, or the inverter power at any given moment is not very high, the fans would not be required. But if that power goes up and the temperature increases, then those fans go into operation to reinforce the natural ventilation. The air would enter from the bottom of the inverter and would come up through the ventilation grills that are on both sides of the inverter. One on this side where I'm located and another on the other side. It uses 3 fans without filters and require no maintenance. This is because the inverter, when it starts to work, for example, early in the morning or after it has been disconnected, those fans first spin backwards to self-clean. The fans do not require maintenance, as I say, in theory, has a very high service life of 250,000 hours at 50 degrees Celsius. We don't expect they will fail, but if they do, they could be replaced. The fan is the only part that can be replaced. In the point opposite from me is a handle that you can take out those fans and replace them. Finally, there's the subject of communications. This inverter can communicate via RS-485, but normally communication is done by what we call M-Bus, or PLC power line communications, which is to say that the data communications of the inverter would be transmitted through the same 3 power cables, meaning data travels via these power cables in parallel with the power. However, different frequencies are employed so that there's no interference and there is no conflict between them, and thus no lost data. We do not need to add any extra device, which is a huge advantage with regards to the other RS-485 Ethernet cable or fiber technologies, because you'd have to trench separately the power and communications, which would require maintenance, which usually gives more problems on the field, especially RS-485 cable, i.e. inverse polarity. And lastly, just to mention that these 3 cables would be connected to Huawei's transformer station STS, which would be protected by an MCCB 200A, which we'll take a look at later.
I'm here to explain Huawei's STS, which is the transformer station from Huawei. It is built out in a 20-foot maritime container which is quite compact, easy to transport and easy to install. It is divided into 3 zones, which are where we have the MV switchgear, the transformer and the LV boards are installed. Additionally, we have the monitoring component, what is the Smart Accu, in which we also have anti-PID modules and a UPS, which is an option that we offer. The STS is easy to install and is compact. It comes with a container and, basically, in the job site you only have to place it on its foundation, then connect the cables to both the medium voltage inputs and to the different inverters that connect to the transformer station. Finally, we promote that the STS is also a smart transformer station because of the fact that all the signals that the transformer stations has, like for example the oil temperature, panel temperature, voltage, open doors, closed doors, all that stuff gets picked up in the central monitoring unit that is installed in the panel that we will see later. All the signals are distributed via RS-485 to the smart logger that is installed here at Smart ACU.
Here we have the Smart Array Combiner Unit, or SACU, and it has some elements inside, which as you see it is hung on the outer wall of the STS. As Xavier explained earlier, the SACU consists of 2 compartments. The first on the left is where the anti-PID modules are, which is optional, although Huawei recommends to include it because it is just a module or 2 modules per station. And as you will see in this case, there are 2 modules because one goes associated with each low voltage winding. This one is connected to a transformer station of 6.3 MVA. So it has 2 units, but the smallest transformer station of 3.15 MVA would only have 1. This is an anti-PID module, and here we have the rest of the components. The main component is the Smart Logger 2000B is the data acquisition system. This component collects all the inverters' data in the field, which in this case there are connected a maximum of 36 inverters and also collects information from the STS, from the Intelligent Monitoring Unit, IMU, that Xavier was showing before. The Smart Logger also incorporates M-Bus PLC power line communications to enable communication from inverter to transformer stations. PLC is incorporated in the Smart Logger, and in the case of the transformer station with 2 windings, as is the case here, an optional module is added, which is the PLC C00 to handle the other winding. Here in the back we have electrical safeguards for communication by PLC. Above we have the switches for the anti-PID modules. They can be disconnected if you want, and then we have over-voltage surge protectors, and lastly a small power converter. The power required for the Smart Logger comes in from below, but then it is converted through this small converter to 24 volts DC. Lastly, all communications, all cables related to the PLC and to the PID would go through the bottom of the Smart Logger. They'll go out of the STS to an auxiliary service panel.
Now I'm going to explain the area of the medium voltage compartment. This is the area where the medium voltage cables land, of what would be the ring of the plant, which we have, in this case, a DVC type switchgear, which means that the first cubicle D is only a cable riser, circuit breaker V, transformer protection with relay, and one output feeder line C to the next transformer station. The relay is pre-configured from the factory, and the motorized CB allows for local or remote manipulation. On the other hand, on this side here, we have the auxiliary service transformer, which in this case it is 5 kVA, although an option is available to have 50 kVA, and the auxiliary service board, where both from PLC and RS485 cables are landed, and other connections the station has are ready for cabling and connection to the common smarter queue. Additionally, we have the part of cooling of the compartment, what is a heat exchanger that allows no exchange of air from outside to inside, that is to say that the outside air is recirculated outside and the air from the inside is recirculating inside, so there's no entry of dirty air, so that nothing can come in, so there's no problems such as dirty filters or that dust may enter the compartment. In this very compartment, it comes equipped with a smoke detector and lighting in the document holder tray. And here is where the PPE is stored, which we also supply with the STS. Next, we will also explain the low voltage compartment. We have two types of STS, the STS 6000K H1 and the STS 3000K H1. For the 6000K, as you will see in the transformer part, there is a transformer with double winding, so we have two low voltage boards. This panel would be replicated on the other side. Because of regulatory issues, the low voltage board is all exterior operation, which means you do not need to enter inside the STS to do any kind of manipulation. In the low voltage board, we have a motorized general ACB of 2500A and remotely reclosing if desired. We've got the 18 MCCB line inputs from each one of the 18 inverters who are downstream from this board, and then we have a series of auxiliary equipment which are not all replicated in the other board. We have a voltmeter and an ammeter, and the temperature of the board which is not replicated in LV board B. Then we have the monitoring unit that is only one for the entire STS, which is the one I mentioned at the beginning. It collects all the signals from the station and sends them to the smart ECU. Additionally, well, we have operational buttons and so on. If we open this board, we can see this monitoring unit, that would be the grey box. And this one up here is an industrial computer that collects and takes measurements such as voltage and currents. We have fuse holders for the PLC and voltage transformer measurement, enabling the voltage measurement of the STS. And we have here the main MCCB of auxiliary services, which from here it takes the 800V AC and sends them to the transformer we saw in the medium voltage side. And we have the over voltage dischargers of the low voltage side for the field connections. We can see the inverter connections, which we can see would be done from the bottom, which comes prepared to simply insert the cables and connect. These, when sealed, would be IP54 so that there wouldn't be any humidity problems inside the board. It also has a ventilation system similar to the one we have described in the mid-voltage area, in that what it does is to inject air continuously to the part of the LV board in order to prohibit all condensation that may be present. Back here we have the power transformer, which in this case is the 6 MVA transformer, which is double winding as opposed to the 3 MVA, which is single winding. It has an expansion tank, what we can see on the upper side. In order for the expansion tank to breathe, we have a dehydrator so that there will be no moisture. The transformer is equipped with an oil temperature gauge which has its trigger alarms in case the temperature reaches 100 degrees. It'll trip both low and mid voltage. It has a Buchholz relay that is on top that would trip because of gas-related issues. We have an oil level meter, which is the one that tells us how much oil the transformer has, and that if there were a maximum or minimum it would also trip. And finally we have the overpressure valve that, also the same, is another mechanism of security. Additionally, we have an emptying valve and a sampling that's over there on that corner, and a sample collection outlet that's over there on that corner, and a filling valve at the top. It doesn't have forced air ventilation, rather it's natural, while the transformer area has a series of holes for any oil leaks taking the oil of the transformer.
Thank you, Elwa and Trevor. Let's introduce Mr. Zhou Xiang, Marketing Manager of Huawei Smart PV, to present Huawei FusionSolar CNI solution, enabling a new era of green and low carbon for various industries.
Hi everyone, my name is Zhou Xiang. It is my great pleasure to introduce our zero carbon city zone, which includes the Huawei FusionSolar Smart PV CNI solution, green ICT, and many more. So let's explore how it enables a new era of green and zero carbon society for various industries. So nowadays, the carbon neutrality has become one of the most urgent missions. At present, more than 120 countries have announced the carbon neutrality plans. So energy industry is an important domain to help achieve the carbon neutrality. Low carbonization, electrification, and digitalization are the essential ways. Huawei Digital Power builds vertical solutions such as green power generation, green ICT, and green travel. In addition, Huawei creates a new smart energy cloud to coordinate the management of sources, the network, the loads, and the storage resources to form a horizontal solution. And this kind of solutions promoting the construction of zero carbon campus in the cities. So next, how does Huawei CNI solution integrate with various industries to help them achieve structural transformation and low carbon energy? Let's check out the details. So Huawei just launched its new CNI solution, which based on the solar plus storage structure and fits for different application scenarios. It's a solar-only scenario, storage-only scenario, solar plus storage, plus charging, and off-grid. So first, this is a solar-only scenario. The typical feature of the solar-only scenario is that the peak power consumption is mainly in the daytime, and the enterprise's power consumption curve is similar to that of the PV power generation curve, from like 80% to 90% self-consumption. And in this scenario, the business model is like during the day, the investor sells electricity to the enterprise at a PPA discount price to meet the power consumption requirements to the maximum extent. Well, the rest electricity is sold to the grid. And this is a solar-only real case. So this case is a manufacturing rooftop. The roof area is around 1,000 square meters. And the initial configuration is like 150 kilowatt installed capacity. And with four 36 kilowatt inverters and 504 310 watt modules. So there are challenges when they plan to try to power the factory with solar. The firstly, you can see the watt power, the watt power in the building next to the PV plant creates the shadow mismatch, so which reduce the system power generation. And secondly, the traditional inverters cannot cut off the arcs, causing the potential fire risks. So to address these two challenges, the owner replaced the 36 kilowatt inverter with a 40 kilowatt inverter, and the corresponding modules were fully equipped with Huawei Smart PV optimizers. So in this case, when the modules equipment with PV modules, only the panels under the shadows are affected. The other modules can still work as they are the highest power points. And also the Huawei inverters support the intelligent arc protection and automatically shut down within the 0.5 seconds. And also we can see this kind of a chart. According to the comparison of the 1 month PV yield data, the optimizers can effectively eliminate the impact of the shadow effects. And also the power generation is about like from the 5% to 7% higher. And monthly the energy yields increase at the rate of the 6 to 6.3%. And the annual revenue of this PV plant increased by $3.7 million, which is really amazing. Okay, so now let's move to the storage-only scenario. With the increasing popularity of the charging piles, the peak load is very sharp, and the power grid reconstruction and the expansion costs are very high to meet the requirements. So if we use the energy storage battery, we charge it when the electricity is in the valley and discharge it when the electricity is in the peak section to maximize the use of the peak valley price differences. So here's a model of the energy storage products. So for the industry, the two main challenges of the energy storage system is the battery power loss due to mismatch of the cells and the potential hazards such as the fire and the explosion caused by the external forces, the high temperature, and abnormal battery operation, such as the overcharging and over-discharging. And the Huawei energy storage solution is an intelligent string-based solution. So as we mentioned at the previous topic, the maximum charge and discharge capacity is improved by 15% through the one pack optimization and one rack management. So Huawei's structure is very unique. And take a 2 megawatt hour system as an example. The annual battery power of the traditional solution is 5.45 million kilowatt hour, while that of the Huawei solution is 6.05 million kilowatt hour, increased by the 11% in revenue. Meanwhile, Huawei solution has 4 levels of protection. The first level is cell level protection, which supports the AI-based short circuit detection. The second is the battery level protection, means the pole voltage is 0 voltage. So when you do the installation, maintenance, and transportation, preventing the security risk caused by the accidentally touch. And the third is the rack level protection. So the multi-level intelligent linkage protection automatically disconnect the charge and discharge loop when the battery pack is like overcharging or the over temperature and like the overcurrent. This kind of scenarios, they will do the auto shutdown. And also the 2-level fault isolation of the circuit breakers and fuses, the anti-reverse connection and insulation resistance detection. The last is the system level protection, which supports the combustible gas detection and the emission devices to proactively exhaust gases to prevent explosion, and the water detection and the linkage protection. So after water flooding, the system is shut off to avoid the electric shock. And here, this is this kind of a model of our 200 kilowatt hour system. So this kind of a system, you can see, this consists of the 12 battery modules, and the total capacity of this is 200 kilowatt hour. And also within this kind of cabinet, there's also a rack management system. So the structure is unique. There's a one pack optimization and one rack management, the structure, to improve our yield, to improve our usable energy of the storage by like 15%. So what if there's a high demand for electricity in the campus? The load is obvious higher than the solar power generation, and the electricity price is high. And let's learn about the solar storage charging scenario. So here is a case of the Huawei Shenzhen campus. The rooftop of this kind of campus is 8,000 square meters, and the initial configuration of the project is a 1 megawatt solar and 900 kilowatt hour energy storage. And Huawei optimizers are used to avoid the shadow of the HVAC devices on the rooftop. And more than 10% power is generated by installing the optimizers. And the installed capacity is also increased from like 1 megawatt to 1.1 megawatt, 10% higher due to the optimizers. And also from the energy storage, the proportion of the green power supply increased from like 58% 8% to 64%. So at present, Huawei could provide the high-quality core components, charging modules for charging stations. Huawei High Charger charging module features high efficiency, high reliability, and high availability. And the Huawei High Charger charging module has a wide voltage range. It supports a smooth evolution for charging piles from 500 voltage to 750 voltage, and even a future 1000 voltage. It is highly compatible with different new high voltage vehicles without renovation. And potentially it could save $2,818 per charging pile, protect customers' investment effectively. And also through the thermal field management and Huawei's patent wing-shaped fan technology, our charging modules support efficient heat dissipation and continuously high power output. Combined with Huawei AI flash charging, it takes less than 15 minutes to achieve from 30% to 80% SOCs. The potential VIP fast charging value-added services may increase the operator's revenue by $6,281 per pile each year. And in terms of the off-grid scenarios, Huawei launched the iPower Cube off-grid, like fuel removal power solution for all scenarios. The intelligent power platform, the PV power generation, and the intelligent lithium battery are used to replace the traditional DG power generation, achieving zero DG operation and zero carbon emissions. The 3 series of iPower Cube covers all scenarios, from small to medium to large cases. As we all know, 5G is booming. Up to now, 160 5G network has been launched around the world. But there are 2 challenges during 5G deployments. The first is high capex and high opex. The second one is the high carbon emissions. So the Huawei's one site, one cabinet solution has a high efficiency and high density design, which enables one cabinet to replace the 3 cabinets, improving the site energy efficiency to 90%. And also, if the one site, one blade solution is used, the site's energy efficiency can be improved to 97%. In addition, the solution requires no floor space, zero rent, and fast deployment within only like 1 hour. Digital acceleration and energy structure transformation holds new requirements for the site power supply. The first is a fast power supply. The second is a converged power supply. The third is a reliable power supply. The fourth is a green power supply. So Huawei Site Power built all scenario solutions in ICT scenarios. It's for communication, IoT, and ICT convergence stations. So Huawei i Super Site solution can provide an outdoor working environment, power supply, security monitoring for ICT equipment. Next one is iPower Site. iPower Site is a one-stop solution for on-site perception scenarios. The stations provide the power supply and network backhaul, and for devices such as bullet cameras, drone cameras, and sensors. The data center industry is rapidly evolving, but faces great challenges to data center construction. Today, it's my great pleasure to talk about the green data center facilities that embrace the carbon neutrality. So this is Huawei Fusion DC, the next generation data center facility solutions. The Fusion DC helps customers build future-proof data centers. So it's a modular and prefabricated design, enables the TDM 6 months for like 1,000 racks and reduce the TDM by like 50%. And its construction mode is environment friendly, reducing garbage and water usage by like 80%, and slashing CO2 emissions by 90%. So it uses the Huawei Fusion Core indirect imperative cooling solutions to maximize the usage of the free cooling the PoE will drop to like 1.2 in North China, so much lower than the traditional way. It also integrates with lots of smart features and AI-enabled energy optimization. The OEM cost is like 35% lower. It fully complies with the international construction standards, has 50 years service life, and provides an earthquake, fire, waterproof design. So this is Huawei's new Fusion Module 2000 Smart Modular DC, which is mainly used in the medium and the large size data centers. The Smart Modular DC features a modular design, achieving the on-demand deployment and the flexible expansion. This Smart Modular DC supports like Huawei Smart Lead technologies. So compared with the traditional lead-acid batteries, the lithium batteries have certain advantages, such as high density, saving the space by like 70% and long service life. In addition, a unified intelligent O&M management platform can be configured, so achieving the space, power, cooling, capacity, and asset visualized management. So improving resources utilization by 20%. So that's all the introduction of our products, and we welcome you to experience our solutions at the various Huawei reference sites to see how digital and ICT technologies transform various industries in terms of energy generation and consumption. So that's all my introduction for today, and thanks for your time.
Thank you, Xiang. Let's welcome Mrs. Xia Yuxin, Marketing Manager of Huawei Smart PV, to present Huawei FusionSolar residential solutions, enable a green and zero carbon life.
Good morning and afternoon, everyone. Welcome to Huawei SNEC 2021 Global Virtual Show. This is Michelle, Marketing Manager of Huawei Smart PV business. It's my great honor to guide everyone through the area today. This year, we launched the second generation of Huawei FusionSolar residential with our newly AI-based PV energy storage and consumption collaboration. We built this solution for zero carbon society and a greener house. This solution focuses on smart power generation and smart energy storage, also the system safety and our newly added smart power consumption. Follow me. Let us take a look at the smart power generation firstly. This is a 415-watt smart PV panel provided by our partner Huanghe Hydropower. You can see it is equipped with Huawei's latest 600-watt optimizer, which will be launched to overseas markets in Q4 this year. As you can see, the optimizer is installed at the back of the panel very easily. Look at the world map. Here you can see many optimizer application cases on different types of rooftops. To maximize power generation, one major advantage is the PV module level optimization, which can increase energy yields by 30% for the same rooftop configuration, as shown in this case located in Dongguan, China. Another advantage is that the impact of shading on PV efficiency is minimized, which means significantly higher solar capacity. Meanwhile, you can check on each PV module energy yields on our FusionSolar app to know better about your solar system. Here is the Smart String Energy Storage System, the flagship product Luna 2000 battery. It was designed with residential scenario in mind. It is 1.3 meters in height, and each module is 5 kWh. Modular design allows customers to flexibly configure the battery capacity from 5 kWh to 10 kWh to 15 kWh. The system supports 2 batteries can be connected in parallel, which means the energy storage battery capacity can be extended to 30 kWh. Smart String architecture allows 30 kWh capacity, which you can rely on 24/7. Here you can see the battery pack. Each battery pack has a built-in energy optimizer. What's the function of that? You can see from the PowerPoint. The traditional mixer use of new and old battery packs cannot maximize the charge and discharge of the entire battery system due to the inconsistent internal SOH in any battery cell. So the capacity of the entire system is no longer than the weakest link. But the Huawei built-in energy optimizer can achieve the charge and discharge individually. Here you can see the comparison. We can achieve the energy usable up to 10%, and also the battery has 100% depth of discharge. You can unleash every last bit of energy. Another focus on the battery is our safety issue. We noticed some battery providers in the market had some explosion and fire accidents recently, and their products were also called back. But Huawei Smart String ESS can achieve the end-to-end safety protection. It has a zero voltage at ports for the safe operation, and also the cell level monitoring in real time. Cloud-based BMS and AI-enabled health monitoring can identify the short circuits in just 20 seconds and disconnect them in 1 ms, covering the bursts and derivatives of the internal short circuits. The incidence of arcs with high energy causes potential fire hazards in PV plants, especially for the residential PV systems which are installed on the rooftop of our buildings that are very close to our residence. The fire caused by arcs will bring huge losses to the investments, assets, and potential safety of the owners. It is difficult to detect the DC arcing by the existing solutions in the industry, where frequently missed and false alarms, resulting in high maintenance costs and power generation losses. Huawei residential inverter uses a neural network algorithm to accurately detect DC arc fault and be able to shut down within 0.5 seconds to effectively eliminate potential fire hazards. And also with these optimizers, the solution can have a rapid shutdown function to zero voltage to ensure the whole safety of the house and people. You may see parameters when I am using the multimeter. The smart and easy operation management is shown in this area. With this app, here you can see the real-time energy flow, enabling you to view the energy flow anywhere and anytime. Energy management can achieve easy control of power generation, storage, and electricity consumption. The component-level power generation monitoring redefines the management of the energy yield of each component. Today, we will also release a brand new digital future AI-powered PV, energy storage and consumption collaboration. We know that PV power generation during the daytime cannot be completely matched within user power consumption, resulting in only about 16% of PV power generation for cell consumption. And the remaining large amount of green power is wasted, which affects the IOI. The release of the AI optical storage and utilization synergy can effectively increase the self-consumption ratio. First of all, based on the big data learning of weather and user electricity consumption habits, AI can accurately to detect the future PV power generation and household electricity consumption, and AI can optimally control the charging and discharging of energy storage under the 3 different scenarios: sunny mode, rainy mode, and our smart home mode, to use the electricity to maximize the green electricity revenue in each scenario and effectively increasing the ratio of our self-consumption to build a green home and a green future. Compared with the 60% of pure solar to 85% of PV with storage, the household green power 2.0 solution combined with our AI optical storage synergy can further increase the self-consumption ratio of green power to more than 95%. Potential smart power consumption ecosystems partners are listed here. Huawei works together with our ecosystem partners to provide a smart home for a better life. The transportation industry currently accounts for nearly 10% of China's carbon emissions. To achieve the carbon neutrality goal, promoting the full electrification of the transportation industry will be an important step for all of us. Huawei mPower provides the end-to-end power solutions, including an onboard power solution and a charging infrastructure solution to help OEMs build better cars and improve our users' experience. The onboard power solution includes the Driver One in powertrain, a battery management system, and an onboard charging system, and a driver cloud intelligent management system. As for the charging infrastructure solution, it contains a wireless charging system and a DC fast charging module. During this year's Shanghai Auto Expo, Huawei launched its AI flash charging solution, a high voltage solution, which accommodates a front asynchronous in powertrain and a rear synchronous in powertrain, realizing a 30% to 80% SoC charging within just 15 minutes. This year, we launched the ArcFocus Alpha's Huawei Inside versions to accelerate the time from 0 to 100 kilometers in just only 3.5 seconds. Compared with the dual synchronization solution, our four-wheel drive solution's NEDC efficiency can reach 86.6%. Such solution would increase the vehicle cruising range by 5%. Well, that's a short introduction of how we build towards zero carbon home and travel with Huawei FusionSolar Smart PV residential solution, brought to you from SNEC 2021. We're looking forward to see you soon. Thank you.
Thank you, Yuxin. Now, let me introduce Mr. Haram Subramanian, CTO of Huawei Smart PV Europe. He will be the moderator of our panel discussion. We will have 6 experienced panelists to share their intelligent ideas and thoughts about technology innovations and thoughts. The stage is yours.
Thank you very much, everyone, to join us in today's panel. There are a lot of listeners eagerly waiting to listen to some of our amazing panelists today. As you know, when we talk about renewable technologies, there's quite a lot of interesting technology behind it. And the way in which the renewable energy is generated, when we speak about PV, the PV technology, the PV generation technology, and the way in which the technology is constructed from a power plant, and the method used to transmit the energy, distribute it to the end users and to the load centers. Actually, it has quite a lot of, let's say, technical, deep, in-depth, sophisticated planning, and a lot of science and engineering behind. And obviously, innovation is going to play a very important role to define this renewable generation and to take it to the future. And for that purpose, to discuss this on what methods and innovations and topics from different people perspectives, to see how we can achieve the global transitions towards the goal of zero carbon society. We're going to talk today with our experts, some big trends in PV, trends in innovation to accelerate the technological advancements. And we're also happy to listen to some project experiences from some of the panelists today. So I'm Hariram Subramanian, in charge of PV utility scale projects in Europe, and I would be moderating today's panel discussion. We have today in our panel Mr. Heikki Siniharju from Fortum, Finland, who leads the solar technology team, and he brings in a decade of experience in developing renewable power plant projects business and also engineering and technology developments. Then we have Mr. Jaideep Sandhu, Director Technical Expertise Department from ENGIE, France, who brings a wealth of experience in renewable projects, O&M, and also in experience in construction, overseeing construction technology development, and greenfield projects. We are very glad to have Mr. Olaf Salzwedel from Ivy Vogt GmbH, Germany. Mr. Salzwedel is the Director of Engineering in Ivy Vogt, and we are eagerly waiting to listen to the experience and expertise from a system integrator perspective and from an EPC perspective. Then we have Mr. Chris Buckland, Technical Director from Lightsource BP. Chris and his team have been responsible for overseeing quite a lot of utility scale power plants and PV projects, including incubating technology innovation into the LSBP BP projects. Then we welcome Mr. Felipe Fernandez, who is the Managing Director of FRVX and Engineering in the panel. Mr. Hernandez have a wealth of experience in renewable energy projects, digital technology, bringing also innovation in market approaches and so on. So we are very, very glad to have this expert panel today. Actually, the panels have spent most of their entire career in energy and the PV industry in a variety of leadership roles, and we will listen to them on their thoughts and ideas on bringing the PV industry into the next future generation platform. Thank you very much, and we will go into the panelists.
Now we have Mr. Jaideep Sandhu from the Technical Expertise Department. He's the Director of Technical Expertise Department from NG, to share some of his thoughts and ideas on some very interesting topics that we will ask Mr. Sandhu. Before that, Jaideep, can you just give a brief overview of your role in your organization?
Yeah, thank you very much, Hariharan. So certainly, so I've been with NG for over 25 years, and as you mentioned, I currently head the Technical Expertise Department. Prior to this, I used to be head of operations for our international business line. In my current role, my team looks after business development support and operational support to the corporate entities and different business units, spanning a whole range of technologies. And as you know, very importantly, a lot of these technologies are renewable technologies. So we provide a lot of support on solar PV, on onshore and offshore wind, hydro, geothermal, battery storage, green gases, which is hydrogen and biomethane, for example. And of course, some of the more traditional technologies such as LNG and gas infrastructure, as well as thermal generation. But a bulk of our effort really goes into renewable technologies. We also provide support to the corporate side as well in terms of best practice guidelines, and also supporting the investment process by having a review of the different investment files which come to our notice.
Brilliant. I think, I mean, as you said, focusing more towards renewable energy, and when we go a little bit towards the utility scale solar here, what do you think? I mean, how was this utility scale solar now compared to, let's say, 5 years ago? Have you seen any, let's say, groundbreaking changes here?
Yeah, a lot of changes. So firstly, when I started looking at solar quite some time ago, but in real earnestness in 2015. So that's almost 5 years ago. And we've seen a lot of change. In NG itself, we had 197 megawatts of solar capacity, the solar PV capacity at that time. Today, we got over 3 gigawatts in operation and several gigawatts under construction. So big change in the way the technology has taken off. And in terms of what we've seen in the field, what we are seeing is improving performances and efficiency, much larger projects, also some hybridization with batteries or even with wind in terms of commercial offerings. The modules themselves, quite a lot of change. So, you know, it used to be polycrystalline, now it's all monocrystalline, the bulk of it. Also with bifacials, increasing energy densities, use of trackers, etc., to increase the yield from the plants, cleaning robots which help with O&M strategy, and very importantly, even on the inverter side, on the electrical system side, increasing voltages. So currently the voltage is 1500 volts. We expect this to rise further in the future. Also, in terms of connection to the grid, there were more and more rigid requirements are being imposed by the transmission system operators to connect to the grid as the percentage of renewables is increasing on the network. And we see that the technology is trying to keep pace, and in fact is keeping pace with the ease of connection to the networks. So a lot of change, I would say, over the last 5 years.
Brilliant. I mean, what I have always, noticed is that very important stress is done on the reliability, especially at the power plant level and also on the technology. Obviously, we are moving into new technologies, new material science, and more control aspects done in software and so on. But we can't wait the next 20, 25, 30, 35 years to see what's happening. But what are your assumptions? I mean, what is to be done, or what will happen in the reliability and the lifetime? Are there any gaps that needs to be filled by the industry, especially from an OEM suppliers?
Yes, so when I look at what we need for reliability, availability, performance of the plant, as you can imagine, a solar PV plant is almost like an infrastructure asset which is sitting there. So people are looking at extended lifetimes of 35, even 40 years now going forward. So you want your plant to be reliable and available and perform to what your expectations are over this period of time. So several things have to be managed in this. So the modules have to be of the appropriate performance, degradation, etc. So it's much more predictable in terms of what we can expect the plant to do. In terms of inverters and the electrical systems, how do we manage to ensure that the equipment is reliable over this period of time? Is it working appropriately? Is it easily maintainable? So in terms of lifetime management as well. So what can we do to address obsolescence and also to avoid electronic waste, which is becoming, as you know, an important subject? What can be done to keep repairing this equipment rather than having to replace it over a period of time? So all of these things are extremely important for the long-term sustainability of the industry and for our business models going forward.
Very interesting. I think when we talk on this topic and when we compare the industry, let's say, to the most popular one, automotive, there are already reliability standards. But in PV, I think there should definitely be some leadership role be taken and to quantify reliability. What are your thoughts there? I mean, is there a gap? Should the industry need to bring in some reliability standardization?
Yeah. So when I compare the PV industry, there are a number of similarities to the automobile industry. So a lot of the quality assurance standards, for example, are very similar to what you would see in the automotive industry, given that it's a very repeatable process of installation. You install millions of modules in the same structure. So there are lots of things which we can learn from the automotive industry. So firstly, when we look at what can we do, obviously it's about the development of the product, the certification of the product, making sure that the products are certified to an appropriate standard, which, by the way, happens, but then you need to make sure that the bills of materials are consistently maintained in the supplies, which are then instituted subsequently. So ensuring all of that. And what we would expect from the manufacturers in this case is also work with us just the way, let's say, a lot of the automobile manufacturers work, is in terms of making sure that there is the service support available over the extended lifetime of the equipment. Also, when we are looking at type faults or serial defects, these are identified early and remedied early, just as they do in the automobile industry. At the same time, we are looking at a lot of evolution taking place in terms of automation, standardization, operating methodologies, which take away the element of human error in the system, and also to optimize the asset performance to the extent possible, just as you would have different systems in the car to doing that. So we would expect those things to also become more standardized and almost, a given in these types of assets. So yes, in summary, expectations to have the same kind of lifetime support which we see in the automotive industry, the quality standards, the standardization of the process, and the serial defect and latent defect addressal at an early stage. Along with, of course, the implementation of more digital and smart systems and controls in the process.
I think I totally agree to your points here. And from the power electronics perspective, we are also looking into the same direction, like bringing in, let's say, extreme amount of robustness rather than just mentioning it as reliability. We also bring another two terms, which is the robustness, because you have the grid, the system have to perform with different grid disturbances, and at the same time also to bring in high amount of resilience to the power plant, because as you said rightly, we are speaking 30, 35, and sometimes even beyond, to build a very sustainable plant so that there is less waste created. And I think this is very interesting thoughts. Thank you, Mr. Sandhu, for sharing.
And if I could just add one thing, also very similar to the automobile industry. The one thing with PV plants is it's all outdoor. So that extra resilience is also required, recognizing the environmental conditions in which these plants operate. And again, there's quite a lot of learning from the automotive industry there as well.
Absolutely. I mean, that's also what we are looking at, different mission profiles, different conditions. You know, project in Europe, when we look into the same technology being used for projects, let's say in Middle East or in India or in some other countries with robust environment conditions, I think reliability plays a very important role, and that should come from technology and also the best practices, as you said, like standardization with and finding out the, let's say, service platform and support throughout the lifetime of the power plant and so on. Thanks a lot, Mr. Sandhu, for sharing your thoughts and insights. Very insightful, and we are very glad to have you today in the panel. Thank you very much.
And thank you very much for having me. It's been a pleasure.
Now we have here a very interesting participant in our panel, Mr. Olaf Salzwedel, who leads the engineering team. He's a director engineering and system integration from IB Vogt GmbH, a German company. And we would like to understand some thoughts and ideas from Mr. Salzwedel, especially on, let's say, the topics that is related to EPC and how an EPC and the developer would look into OEM and innovations. So a question to you, Mr. Salzwedel, is from the technical side, you know, we are also looking into the EPC activities, quite a lot of activities from planning, you know, procurement, taking the right decision for the technology, then comes the engineering design, construction activities, managing the field staff, subcontractors, etc., etc. So what are the challenges faced by the EPC in the solar industry?
So obviously there are a lot. So we face on a daily basis, since we are a system integrator, and you mentioned where we are active and the fields we look into. And obviously, as an integrated developer, we try to maximize the value of projects in our best interest and the customer's interest. And we spend a lot of effort in achieving this in our projects, for example, from engineering perspective. But we are not alone in the field, and we provide certain input for the optimization of projects. But you asked for difficulties in these days, mainly, I guess, and this comes from my perspective, not especially from the engineering world and products. We'll come to that. So pricing obviously is something which is under discussion also in our organization in terms of modules, raw materials, steel, etc., and this impacts our projects in a way, so that we have to consider the options, let's say. When it comes to the engineering perspective, so projects in the past used to be simple from my perspective. Looking into the module side of the business, we were able to exchange modules right before start of construction because products seem to be similar. Now we are talking about something what we call internally the module zoo, because of the various options, and this makes life complicated for the engineering team inside of our organization. So module decision impacts design, and this is what happens quite often, to be honest, and makes life complicated. But from company perspective, challenges at the moment: module pricing, steel pricing, and the impact for the projects.
Understand. I think, as you said, a very interesting term like module zoo and module affecting, let's say, the technology decision as well. So we are also now moving into large current modules, lower VOC kind of modules, and some innovations are being seen in the industry as well. So are there any key points from the OEM perspective, from, let's say, from the technology provider perspective, that is needed to fill the innovation gap? Or there anything missing that will help you build power plants much better?
So what is much better? Yeah, that's the question. Yeah.
Yes.
So cheaper, higher yield, please. More DC capacity on a field without impacting the yield too much. So this is what we are looking for, and higher efficiency modules certainly help in this regard. So different module technologies we consider in our projects. Honestly speaking, I cannot recommend what to develop, because we are not developers, so project developers, but we do not develop equipment and material, etc., etc. Anything which helps to bring down prices. This is standard answer from everywhere, I guess. And important for us, also for the future, and even more in the future, is since we operate plants and guarantee performance ratio, availability also in long-term O&M contracts. We are keen to consider products in our projects which allow the highest availability, because this is key. Yeah, so the yield predictions, for example, internal and external, proved in the past that our designs and the realized projects meet the expectations as long as there's perfect availability. So any product which brings down availability must be considered to be a bad choice. Yeah. So this is what we are looking for: durable products.
Yeah. Understand. So I think the key takeaway is to look into product, let's say, availability, high reliability, and also focusing it around the modules. But since you are in this field of EPC activities, system integration, how quickly do you think any new technology can be absorbed? Is there a risk for you or for your customers, or do you think you could immediately try something new? What would be the case?
Yeah, so
generally speaking,
yeah. So generally speaking, we say we are not the first movers in certain technologies, and we try to understand first what does it mean to us. We have set up a couple of years ago a small team called Technologies and Applications. And the small team looks into the latest developments in the market, and from our perspective, and new technology is considered to be something which we did not yet consider in our projects. So several years ago, when trackers used to be new to us, we started to look into this, to dig into this, and to understand what the implications are for us. And later on, bifacial modules, also from the past, floating PV, agri PV, these things, and we spend effort on this in order to understand what does it mean to us. And once we understand something, then we are in a position to consider this in our projects. And thereafter, once considered, we spend again effort in order to check whether our assumptions were right, especially concerning, so we have tracker experience in the meantime, and we also looked into bifacial module installations and checked our assumptions, and this is how we approach this. Yeah? So we do not just take something from the market and give it a try, but we investigate, we look into this from a technical perspective, we check, we simulate, we integrate in our designs in order to understand what does it mean, and certainly impact for the financial modeling.
Yeah, I understand completely.
Yeah. So I think this means then that we are, so we work on this and try to find a way to integrate things into our projects once we understand that it must be beneficial. Yeah. And the same applies obviously for battery energy storage systems. We look into this in several years. Yeah, so we are in a position to work on this. We do this. We have our team also together with procurement, obviously, looking into this to understand the topic and then integrate in our projects. And therefore, we are willing to look into this. We are active in this field.
Very interesting. I think the key takeaway is, I mean, when we look into, let's say, a leader in the EPC field, a very, very deep technical due diligence is needed on new technology that comes in, and then understanding this from various aspects on the new technology, like investigating the yield assessment, reliability, the product, etc., and how it will impact your company as well as your customer into the lifetime of the power plant. I think this is a very good key takeaway, and I think that's also the way the industry is driving towards, to come up with high reliable products, but at the same time bring opportunities and possibilities for companies like you to do a deep technical due diligence to understand the depth of the product from the module to the, let's say, to the substation or wherever we are linked in. Perfect. Thank you very much, Mr. Salzwedel, for sharing your thoughts and ideas from the EPC perspective and system integrator perspective. These are very valuable inputs, and I think this will be very useful for our listeners to understand the perspective on the field as well. Thank you very much.
Thanks a lot.
So now we have here Heikki Siniharju, who is the head of solar technology, Fortum, from Finland. Mr. Siniharju will share some of the interesting thoughts and insights on some large, very interesting power plants that has been built with bifacial and monofacial, and also some thoughts on how the PV industry will take on. Here, Mr. Siniharju, we want to get your feeling first. What are the exciting developments you have seen in the PV industry in the recent years?
Good, thanks, and thanks for having me here. So super excited, and thanks for the invitation. Well, from my side, of course, it's important to start with the fact that solar is the most cheapest electricity generation source as we speak. So that has been tremendous excitement and development, and we have a clear technical roadmap that this continues taking place. So this, of course, makes me super excited. At the same time as we speak, so I'm very, very kind of curious and excited about the opportunities to integrate PV with the batteries, with the electrolyzers, and gain the synergies both from investment and operational point of view. And then, of course, more standard technical dimensions like bifacial modules, of course, developing property cleaning, string inverters, gaining more and more momentum, and there, of course, this plus minus 1500 volt design. So those make me super excited.
Yeah, absolutely. Very interesting. I mean, I think one exciting thing is also your large scale, ultra megawatt scale project with string inverters in India. I think this is the Jaisalmer India project with bifacial, some percentage, and with monofacial. Are there any interesting things that you have learned in this project, or anything you want to share on this project as well?
Sure. So yeah, the Jaisalmer 333 megawatt project have been a super important project for us, and of course, most importantly, that we have been able to now implement it in safe, sustainable way on time, budget in these quite challenging times, I would say. And of course, that's a lot to thank our great Indian colleagues and our global partners. But then from technical point of view, it has been exciting projects. We have went first time big way with the bifacial modules there, with the string inverters as well. And then once again, we have implemented a fully dry cleaning solution, so robotic cleaning solution in this plant. So from technical point of view, it's a very interesting project as well.
Very interesting. So you are already taking AI technologies to the next level to bring in O&M efficiencies. I mean, this is a very big, huge project in India. And so what is the trend and what do you think will happen? Do you think there'll be large scale single sites or multiple single sites of smaller scales? What do you think? Do you see any economy of scale building a large scale? Let's say you want to build a 1 gigawatt plant in the future. Do you want to break it down into 10 pieces of smaller blocks, or you want to build it like bulk, big, one gigawatt? What are your thoughts on this?
Well, of course, to start with, so of course there are economies of scale, so both in the operations and in the investment, but the delta gets a bit smaller and smaller when you start to go above the, let's say, 100 megawatts. But this is, of course, at the same time very market and case specific. So, for example, if you have a really high connection grid cost or some other one-time high DevEx cost, so of course, bigger you build, so this one-time item basically disappears. Then I would say that we have been building big plants in India. This has been quite of a market opportunity as well. And now when we start building more and more projects to Europe, so the average size would naturally come a bit down.
Okay, quite interesting. I mean, that's also something we have been trying to look into it. How would the large power plants will be in the future, or the futuristic large power plants? Are there any wishes that you want to say as a pioneer in solar industry? What changes you want to see in the industry?
Well, I think that now over a decade of work in solar, so I have seen a lot of changes, and I've been super happy about them. Like an example, that when we started auditing about 10 years ago, our manufacturers, so they were a bit surprised when we brought a long list of sustainability questionnaires and inspection items. And today these start to be industry standard practices all over the place.
Yeah.
At the same time, as a most sustainable electricity generating source and an industry to take care of that, we are sustainable in all the parts of the project value chain. So, for example, we should be using in a water scarce and dry locations water to something else than panel cleaning, and luckily even there as well. So the dry cleaning solutions and robotic cleaning solutions start to be rather industry standard.
Yeah.
But then where I of course see that we can always be better and we should be better is that the drumming the drums in the political scheme. So we need everybody to know that this is the most sustainable electricity source, and the political decision makers all over the world that give their support for of course for a solar, for the renewables, but for the whole green transition.
Yeah, so I think we are in the same thoughts like you. I mean, environment, health, safety, and sustainability is one, let's say, fundamental building block, and above it comes, let's say, the power plant, the electrical disciplines, and so on. And as you rightly said, like dry cleaning, which you have already, I think you have done that in the project in India, right, with the dry cleaning. So I think this is going in a very good direction to bring more sustainable practices in a large-scale PV power plant. And thanks, Mr. Siniharu, for your thoughts and sharing us your very valuable inputs. And it's always a pleasure to speak with you, and nice to have you today in our panel. Yeah, thank you very much for joining.
Thank you.
So also in the panel, we have Mr. Fabrizio Bizzari, who is the head of solar innovation from Enel. Mr. Fabrizio Bizzari have a wide experience of more than 25 years in engineering and construction, and also a lot of experience in the R&D. Mr. Fabrizio Bizzari was one of the key person involved in the construction of the first bifacial SJT factory in the world. And he's managing innovations and R&D topics with Enel. We wanted to ask one very important question from the innovation side. As we are speaking now, various technologies, we are talking about grid-tied inverters, and we would be having in the future technology that can do grid forming. So, Mr. Bizzari, what do you think is the key technology needed and the use cases for grid forming, and what kind of scenarios you are looking for with grid forming type of inverters in the future?
Sure. Thank you, Hariram. I think that in the past, grid forming requirement was only concept just for small scale system and island system. So small hybrid system that have not connection with the grid. With the grid, or they was just connected with a small grid and weak grid. Nowadays is more important is always a growing of plant connected to the grid, and thinking to the future in which we will have a big percentage of renewable plant integrated in the grid. We have to think to something to maintain the control and the grid stability. So how we can maintain the grid stability, thinking to renewable penetration that are more or less even more than 60%. We are talking about in Europe, for example, there is a program in which we are talking about the completely integration of 100% renewable energy. So thinking to that kind of future, we have to understand, we have to fight with some challenges that are affecting the stability of the electric grid. So in this context, we are just operating in some countries in which, for example, there is some issue. Thinking to Australia, for example, we know that we already have an higher penetration of renewables. And so in this context, we are just operating, thinking to solution to maintain the stability of the grid. In this sense, for example, we are just facing with issue and topics typically of a grid forming inverter, like frequency control, voltage control, system protection, fault ride through, and voltage recovery. And so we have to model and simulate this kind of working of equipment. So it's important for us to thinking in the future, because our plant are bigger plant, of more than sometimes even more than 500 megawatts. So approximately, sometimes we are thinking to plant even bigger. And in this kind of plant, I think that we will have the need to imagine a working of the inverter that is the core of the PV plant, like having this kind of inverter that have a behavior like the synchronous generator with a large rotational inertia, we know. And so we are thinking to something that can even imagine to manage this kind of issue as like a typical generator. So we are thinking about inertial, synthetic inertial, for example. We are fighting with all the things related to the sun specification of the grid, because we can imagine that in the future we have to even to fight with the secondary regulation. And so in that case, it could be very important even to work together with the storage system inside the plant. And so thinking to hybrid system, which there is the storage inverter that can make some activities that we call grid forming activities integrated with this kind of hybrid plant.
Very interesting, Fabrizio, because we are talking about, let's say, technologies that will bring in 100% of renewables in the grid. And you mentioned Australia as one of the key challenge where grid forming capabilities are very important. We are also seeing, let's say, needs for grid codes to satisfy grid forming technologies. For example, what are the capabilities of grid forming methods like harmonics as a sink? What is the short circuit current contribution from grid forming, etc.? Do you also see business case for grid forming in Europe, Mr. Bizzarri?
Yes, I think so. So thinking to the Europe, I told that we are thinking to reach in 2030 a very challenges penetration of the renewables. And so there are some countries, for example, in Spain, in which there is even this kind of issue, thinking to the, for example, the energy management. Today, we are even, we know that in Spain, there is even a strong regulation, considering even the approach, the forecasting of the nowcasting of the renewable energy, especially for the wind and solar. And so it became very important to not only adapt the functionality of our plant, but even thinking before the construction of the plant, how we can contribute to the stability of the grid. And so obviously the inverter is something that will be key for this kind of the generation. So obviously we know that inverter is key even for other renewables. So in the future probably the domination will be essentially from generator that have power electronics on board. And so I think that could be very interesting to have a kind of generator even in a big plant, in a bigger photovoltaic plant, that can manage in a very small piece of the power the different services that they can do for the grid. So sometimes we are talking about centralized system to manage the interface with the grid, but obviously having some kind of inverter that can manage this at small power could be very good.
Perfect. I think this is also one of the directions where we are looking to bring in solutions with the grid forming technology, as this is one of the key area where we wanted to have the power electronics and the control together with the storage to create concept very similar to virtual synchronous machines. And thanks to Enel also having similar ideas and thoughts so that we can all attain the 100% of renewables, not only in Europe, but also in various countries with PV technologies. Thank you very much, Mr. Bizzarri, for sharing your thoughts and ideas in the panel. And I think our listeners might have got very valuable inputs from you today, and we will see a lot of sustainable renewable power plants in the future. Thank you very much.
Thank you very much, Raman. Bye.
So now the question to Mr. Chris Buckland from Lightsource BP. So welcome, Mr. Chris Buckland, to the panel. Mr. Buckland, we have some very interesting thoughts here as we want to know about some technology and innovation. So as you know, for the energy transition, we need more of everything. We want to have better grids. We want better technology from the power electronics, inverter, maybe AI technology, storage technology, new markets as well. Do you think virtual power plant could unlock the potential here, or do we still need to think more like large utility scale power plants, or also focus a little bit in Europe on distributed power plants with micro generation, small and medium sized power plants? So what are your thoughts in this, Mr. Buckland?
Thanks very much, and thanks very much for the invitation today to participate in this event. I think realistically, the ambitious goals that we have, 2050 and within Europe probably even earlier, going for the carbon neutral aspect, we're going to need that and everything else together. So ultimately, whether it's the large scale utility plants and or very small scale and aggregated domestic and the commercial industrial, all of these will need to work together. And then that is actually where we come back to the AI platforms. The question is, will the AI platforms almost be ready on time? There is not a golden solution out there. There isn't the Google of AI platforms as far as energy is concerned, those kinds of things. And of course, we have batteries to deal with as well. And if we talk about batteries, then maybe one day we have vehicle to grid. So everything needs to work together. C&I, commercial, industrial are useful, but they tend to be subscale. Basically, a manufacturing facility generally can't have enough solar panels on its roof, which means that then the solar panels are adjacent to the facility. That's the kind of PPAs we're doing here in the UK and elsewhere. But generally, it's going to be a lot of all of the above, plus the wind. I think the interaction between solar and wind also needs to be taken into account. B2G we've mentioned. Clearly, most of the storage, lithium-ion storage, is going into vehicles. Most of those vehicles will be parked up. Now, there are two B2G areas I think that are interesting that we are seeing in the market. One being the domestic, but also let's say the delivery lorries, the post office vans, and the subscale. So all of these storage units will be exceptionally helpful for moderating the inherent variability of solar and wind as you put them together and as we aim for this carbon neutral world.
Very interesting. I think you touched on storage, battery and technologies, and also EVs. Do you think that, let's say, in countries where there are a lot of demand to have huge data centers, they have, like for example, in Ireland or in some other countries, do you think if the data centers would participate also in the ancillary service markets, do you see that as, let's say, a potential competition for the PV as well, when PV plants would also service and provide some ancillary services? What are your thoughts here?
Short term, certainly, and within the UK, as you may be aware, that DSR, demand side response services, are already being monetized. We're seeing those demand side response services now spreading across Europe. Italy already is relatively clear, and Spain probably not too far away. So DSR, demand side response, turn down in association with turn up, is definitely a solution. Of course, ideally, we would all have pumped storage, and that would just solve the problem for everyone. Fine in Norway, fine in Austria, probably. But the majority of the world, we're going to need to buffer off that energy in a shape or form. Longer term, which you're probably aware of, we're working together with our big brother, BP, looking at the green hydrogen solution. So when solar can produce green hydrogen, we then have an energy form which can then be released as and when it's needed. Again, coming back to this intermittency, although predictability, of the renewables energy sector.
Yeah, very interesting. I think with hydrogen, I think one could even plan for a long-term storage and buffer the gap. Very interesting, very interesting. Thank you very much. Let me ask you a question from, let's say, from the lifetime construction and quality, because a lot of our listeners are also interested to get your opinion on that. So actually, when you look into a power plant, obviously you have the equipments, and you would go for qualifying the equipments, and also on the construction quality plays an important role when we talk about availability of large-scale power plants over the lifetime. So what would be some key KPIs that you want to generally look into the selection of the equipment, and even as a general contractor? And are there any lessons learned from you? You want to share that to our listeners? Lessons?
Absolutely, and as you know, Lightsource, we've been in this space for 10 years now, or slightly more than 10 years, and delivered more than 300 solar plants. So believe you me, there are enough lessons learned. I think we have to start definitely with the safety, the safe operation and construction of these sites. That's an absolute baseline. So companies, when we're looking at onboarding new equipment, or indeed new products from established providers, then one of the first steps that we go through is the compliance and our confidence in terms of the safe operation of that plant and the delivery of that plant. The other thing I have to say that we look at, even with established providers, with a good Bloomberg rating and with good distribution across the market already, is when a new product comes online, we go through almost the same process in terms of qualification as we would for a new supplier. Now, it is true to say that at Lightsource we are agnostic, so we will go to market for a qualified provider. We don't have lock-in with one or two providers, either on modules or on the inverter side. So we start with health and safety. We start with the confidence that this new product or this new supplier will be able to deliver the technical solution. And then, of course, we have to look at the commercial aspects, because there's no point in buying something that ultimately, over its lifetime, and I would focus on the lifetime cost of these plants, where it's less competitive. Lightsource, here we're moving from 30 to 40-year lifetime on the solar plants. So longevity of a product, as well as its warranty, but the longevity more than the warranty, definitely drives a lot of our discussions, particularly interesting enough once you get beyond the 30-year lifetime. So string inverters, possibly we would have over a 40-year lifetime a slightly higher replacement rate than a central inverter, for example. Nonetheless, maintaining a site with string inverters, such as from Huawei, is intrinsically more cost efficient because you can deal with that with a easier logistics flow than trying to maintain or refurbish established central inverters. So health and safety, reliability and confidence building, then it's the costing and the pricing over the lifetime of the project, not just at the upfront costs. And that, I think, is important, together with the real support that we will then get from these providers. In the best world of the world, you get a very good quality module, very good quality trackers, inverters, but things do go wrong because we deploy so many millions of them. And having that ability to engage with the manufacturer, for the manufacturer to have local support in the right time zone, and evidence of response, and that's definitely a lesson learned. Evidence of response of a manufacturer supporting us in the operation of these sites definitely plays a role in follow-on business.
Brilliant. So I have very key takeaways also for us and also for a lot of listeners, like health and safety, reliability, evidence of response, quality, and looking into the lifetime of the product and the project. So there needs to be quite a lot of technological innovations that would also address these things. For example, like conditional-based maintenance methods, so that maintenance can be done with more, let's say, technological evidences and so on, rather than making it periodic process. Thank you very much, Mr. Buckland, for your thoughts and insights. Very valuable, and it's a pleasure to have you in our panel and to know your ideas. And thank you very much once again.
Right. Appreciate the time again and the opportunity to suggest some insights from what we have on this side of the pond. Okay.
Thank you. Bye-bye. So now we have Mr. Felipe Hernandez, who is the Managing Director of FRV Exxon Engineering. So the question to you, Mr. Hernandez, is what is the technology trend and the biggest challenge of utility scale storage solution from your point of view? So what are your thoughts in this? We would like to have our listeners enlightened with your feedback.
Okay, first of all, thank you to Huawei to invite to take part of this panel. It's an honor to share this time with you. So talking about the technology trends, I think that it's the time to integrate the storage with the power generation. At the moment, some solutions, some projects have been done, but it was not really integrated. Most of the times, you take a BS solution that is connected in medium voltage, but it's like some kind of external connection of a battery to the system. It's not fully integrated with the generation of the project. So my feeling is that the next step should be this kind of DC coupling, where you are able to connect the batteries and the modules to the same electrical equipment, to the same inverter, power conversion systems, in order to manage in a more efficient way all the energy flows that we are doing today.
Yeah, I think it's very interesting because DC coupling will also avoid, let's say, or will improve some more efficiency in the system. And DC coupling could also be a strategy that will not load the grid too much because you don't couple again in the medium voltage or in the HV side. And I think we are having similar thoughts like how you are thinking on the DC coupled solution. But what do you think about, let's say, some revenue streams for battery storage? Obviously cost is a pain point, but we need some revenue streams as well. Do you see this solution with DC couple deployed, let's say, in what size and which parts of Europe do you think is interesting as well?
I think the key is try to define the system as flexible as possible, because it's what will allow to you capture different revenue streams. Now, depending on the countries, there are different very interesting streams. In some areas, energy arbitrage. In other areas, you can manage the frequency service, the ancillary service, but it is in a very quick evolution change. So really, no one could guarantee what will be the main revenue stream in 5, 10, 15 years. So what we try to do is we try to define very flexible system that will allow us to evolve with the markets and the technology. So maybe sometimes we will be playing in ancillary service. Maybe other times we will do peak shifting with the DC couple. Another time we will play directly to energy arbitrage, moving the energy from the midday when we start to see very low on market price to the evening. So I think the key will be on this side. In flexibility, have a system that is able to be very flexible to take all these different options. Some of them we don't know yet what will be, and also a very power software that allows you to do all this energy and service management. And it's where the difference will be done in how you use your system, how you are able to read what is happening in the grid to take this revenue stream.
Understand. So which countries do you see maybe interesting in Europe as we might go on this ancillary services, peak shifting and so on? Spain, for example, or Spain, south of Europe or north of Europe?
Yes, south of Europe will come. There are ambitious plan in Spain to deploy storage in the next year, or in Italy, but there are markets which regulations still evolve yet. Right now, in the short term, for us, the best market is not a promise, it's a reality, is the UK. We have already a couple of projects under operation, storage projects in UK. We are going to do a very big one in the next months. So it is a market that has evolved has a strong commitment from the authorities to get the net zero grid in a short time. So they have defined a very attractive market for this kind of flexibility service. That what means is that right now the storage is a viable solution with not any kind of public support, just relying on the market revenue stream. So right now, UK is the most interesting country, and in the midterm, probably South of Europe will be take this leading role.
Yeah, very good. I mean, I think very interesting to get your thoughts and ideas here. And I think storage is one important necessity to have this global transition with, let's say, renewables, and to achieve the 100% renewable target that everyone is looking, and to bring in the goal of zero carbon, let's say, smart society. Thank you very much, Mr. Hernandez, for joining and enlightening us on the very, very important topic related to storage and what we will see in the future and which markets will be interesting for us, let's say. Thank you very much.
Thanks to you for sharing this time. Thank you.
Thank you. Bye-bye.
Bye.
We had a very interesting discussion today with our experts. Got very deep insights on the technology innovation, as well as how the PV industry will be leading in the next years and days to come. Solar energy have come quite a long way, but as we have understood from our panelists, there is actually also a need to bring in much more reliability, resilience, and bring in concepts like grid forming technology coupled with storage solution, and also to bring in a very high amount of robustness in the power plant, because in the end, after all, everyone is looking towards LCOE and together with the storage on the LCOS. So we also need to have digital technologies inside the PV plant solutions. We have seen, for example, from one of the panelists talking about robotic cleaning. So we would have more of AI-based technologies in the PV power plant. Grid stability is getting more and more important. Operation under weak grid situation with a large amount of penetration of renewables is getting also imperative. So I think in the panel discussion, we have got a variety of insights. Thanks a lot to everyone for joining today in the panel. And I believe it has given a very good, let's say, understanding also to our listeners from the industry stalwarts here who have joined. Until then, I'm looking forward to the next discussion with similar panelists. Until then, thank you very much for joining, and thanks for making this panel discussion very successful. Thank you very much, everyone.
Thank you so much for joining and staying with us. We are almost at the end of today's event. It is our great honor to have you today to witness the SNEC 2021 online and how Huawei continuously builds a better, green, and smart world. Thanks for your time and wish to see you next year in SNEC 2022 in Shanghai. Stay safe and sustainable. Take care and goodbye.